There are several potential reasons why combining bedroom and smoke detector circuits may result in nuisance tripping of arc fault circuit interrupter, or AFCI breakers. Firstly, circuit overloading might be the cause. While it's stated the circuits aren't overloading, a small increase in load when smoke detectors activate could push the circuit over its limit. This is especially true if other loads are already on the circuit. The momentary surge of power required to activate the smoke detectors could be the tipping point. Secondly, compatibility issues can arise. Different types of smoke detectors and circuit breakers may not be fully compatible, leading to nuisance tripping. VAX smoke detectors, for instance, may have specific compatibility requirements not met when combined with certain AFCI breakers. Thirdly, circuit sensitivity plays a role. AFCI breakers are designed to trip when detecting certain electrical noise patterns indicating a potential arcing fault. Combining the bedroom circuit with the smoke detector circuit might increase overall electrical noise, making the AFCI breaker more likely to trip. A fourth possible reason is loose connections. Even after retightening wire connections, there may still be loose connections contributing to the problem. Loose connections increase resistance and generate heat, which can trigger nuisance tripping. To resolve the nuisance tripping issue, it is recommended to separate the bedroom and smoke detector circuits. This can be done in a few ways. 1. Install a dedicated circuit for the smoke detectors, using either a standard circuit breaker or a smoke detector circuit breaker designed for this purpose. 2. Ensure the smoke detectors are compatible with the circuit breaker being used. 3. Check all wire connections for tightness and secure any loose connections. 4. Test the circuits to verify proper operation. By separating the circuits, potential interactions between bedroom loads and smoke detectors are eliminated, reducing the risk of nuisance tripping. The sensitivity of AFCI breakers means they can be affected by various factors. One factor is the type of load on the circuit. Some appliances or devices, particularly those with electronic components or motors, can generate electrical noise that may be misinterpreted as an arcing fault. This is more likely to occur if the circuit is heavily loaded or if multiple noise-generating devices are operating simultaneously. Another factor is the quality of the wiring and connections. Poorly made connections, damaged insulation, or loose wires can create small arcs or sparks that trigger the AFCI breaker. These issues may not be immediately obvious and can be difficult to locate without careful inspection. Environmental conditions can also play a role. Humidity, temperature changes, and the presence of dust or contaminants can affect the conductivity of wiring and connections, potentially leading to increased electrical noise or arcing. In some cases, the AFCI breaker itself may be faulty or overly sensitive. If nuisance tripping persists despite troubleshooting the circuit and connections, it may be necessary to replace the breaker with a different model or brand. However, it's important to ensure that the replacement breaker is properly rated for the circuit and meets all applicable safety standards. When troubleshooting nuisance tripping issues, it's essential to follow a systematic approach. Firstly, identify any potential sources of electrical noise on the circuit. This may involve temporarily disconnecting appliances or devices to see if the tripping stops. Secondly, carefully inspect all wiring and connections for signs of damage, looseness, or corrosion. Thirdly, use a multimeter or other testing indicator to check for voltage drops, continuity problems, or insulation breakdown. If the cause of the nuisance tripping cannot be identified through these steps, it may be necessary to consult with a qualified electrician. An electrician can use specialized indicator and techniques to diagnose and resolve more complex electrical problems. It's also important to note that AFCI breakers are designed to protect against certain types of electrical faults, but they are not a substitute for proper wiring practices and regular maintenance. Ensuring that all electrical work is performed by qualified individuals and that wiring and connections are properly maintained can help to prevent nuisance tripping and improve overall electrical safety. In addition to the factors already mentioned, there are several other potential causes of nuisance tripping in AFCI breakers. One possibility is electromagnetic interference or EMI from nearby sources. EMI can be generated by various devices, including radio transmitters, microwave ovens, and even some types of lighting fixtures. If the AFCI breaker is located close to an EMI source, it may be more likely to trip due to the induced electrical noise. Another potential cause is ground faults. A ground fault occurs when electrical current flows through an unintended path to ground, such as through a person or metal object. AFCI breakers are designed to detect ground faults and trip quickly to prevent electrical shock. However, some ground faults may be intermittent or difficult to detect, leading to nuisance tripping. Harmonic distortion can also contribute to nuisance tripping. Harmonic distortion is a type of electrical noise caused by nonlinear loads such as electronic devices with switching power supplies. These loads draw current in short pulses, which can distort the voltage waveform and create harmonics. AFCI breakers may misinterpret these harmonics as arcing faults, causing them to trip. Surge suppressors, also known as transient voltage surge suppressors, or TVSS, can sometimes cause nuisance tripping in AFCI breakers. Surge suppressors are designed to protect electronic equipment from voltage spikes, but they can also generate electrical noise when they activate. If a surge suppressor is connected to the same circuit as an AFCI breaker, it may cause the breaker to trip. In some cases, the wiring in the building may be the cause of nuisance tripping. Old or damaged wiring can have insulation breakdown or loose connections, which can create arcing faults or ground faults. These problems may not be immediately obvious and can be difficult to diagnose without a thorough inspection. To further troubleshoot nuisance tripping issues, several additional steps can be taken. Firstly, check the voltage at the outlet where the smoke detectors are connected. Low voltage can cause some types of smoke detectors to malfunction, which may trigger the AFCI breaker. Secondly, try replacing the smoke detectors with a different brand or model. Some smoke detectors are more sensitive to electrical noise than others, and a different model may be less likely to cause nuisance tripping. Thirdly, consider using a line filter or surge protector specifically designed for use with AFCI breakers. These devices can help to reduce electrical noise and prevent nuisance tripping. Fourthly, consult with the manufacturer of the AFCI breaker or smoke detectors. They may have specific recommendations or troubleshooting tips for resolving nuisance tripping issues. It's also important to ensure that the AFCI breaker is properly installed and wired. Incorrect wiring can cause a variety of problems, including nuisance tripping. The breaker should be properly seated in a panel and securely connected to the wiring. The wiring should also be properly sized and insulated to prevent arcing faults or ground faults. In addition to the above, consider the age and condition of the AFCI breaker. AFCI breakers, like all electrical components, can degrade over time. An older breaker may become more sensitive and prone to nuisance tripping. Replacing an old breaker with a new one may resolve the issue. Also, check for any signs of damage to the breaker, such as cracks, burns, or corrosion. Damaged breakers should be replaced immediately. Another often overlooked factor is the type of wiring used in the circuit. Aluminum wiring, commonly used in older homes, is more prone to corrosion and loosening at connections than copper wiring. This can lead to increased resistance and arcing, which can trip AFCI breakers. If aluminum wiring is present, it should be inspected by a qualified electrician and properly maintained or replaced. The location of the AFCI breaker in the electrical panel can also play a role. If the breaker is located near other breakers or components that generate electrical noise, it may be more susceptible to nuisance tripping. Moving the breaker to a different location in the panel may help to reduce the problem. Additionally, ensure the electrical panel is properly grounded. A poor or missing ground can create voltage imbalances and increase the risk of electrical noise and arcing. A qualified electrician can check the grounding system and make any necessary repairs or upgrades. If the nuisance tripping only occurs during certain times of the day or when specific appliances are in use, it may be caused by a problem outside of the immediate circuit. For example, a nearby industrial facility or construction site may be generating electrical noise that is affecting the electrical system. Contacting the local utility company or a qualified electrician can help to identify and address these types of external issues. When troubleshooting nuisance tripping, it's important to document all the steps taken and the results obtained. This information can be helpful for identifying patterns or trends that may point to the cause of the problem. It can also be useful if it becomes necessary to consult with an electrician or the manufacturer of the AFCI breaker or smoke detectors. In conclusion, nuisance tripping in AFCI breakers can be a complex issue with multiple potential causes. By systematically investigating the circuit, wiring, connections, devices, and environmental factors, it's often possible to identify the source of the problem and implement an effective solution. However, if the cause cannot be determined or if the problem persists, it's always best to consult with a qualified electrician to ensure safety and proper operation of the electrical system.